Welcome back. I'm Miss Awinup, your grade 10 maths teacher. Okay, in our last lesson, we looked at bearings, and bearings was a wrap-up of our Term 1 units. Okay, now, in today's lesson, we are going to do a review of what we covered so far in our Term 1 unit. Okay, so we're going to look at not necessarily a lesson by lesson, but we are going to look at the important things that we have covered over the course of the Term 1 grade 10 unit. Okay, so first thing we looked at, we looked at types of triangles. And those different types of triangles included the right angle triangle. Okay, I won't draw all of them, just a few. We looked at the obtuse angle triangle. Okay, and we also looked at the equilateral triangle. All right. Now, different types of triangles, but one thing they have in common is that they have an angle sum, okay, angle sum or total sum of all the angles here equal to 180 degrees, okay? So if I have a triangle like this right angle triangle here, and we say this angle here plus this angle here plus the 90-degree angle will give us a total of 180 degrees, okay? Now, we looked at finding, or we can use the angle sum here to find the value of any of the missing angles in a triangle, okay? When we were done with this, we moved on into squares, all right, and square roots, okay? Squares and square roots. Now, remembering our symbols here, all right, we looked at squaring a number and taking the square root of a number, okay? When we looked at the square root, we find square root of very large numbers, very small numbers, and numbers that are not square numbers, okay? So we used estimation to find the root of numbers that are not square numbers. How did we do that? And the method was to use the two square numbers before and after the given value and then divide by 2 to give us an approximation, okay? After looking at squares and square roots, we moved into Pythagoras, okay? Pythagoras. Remember, Pythagoras is a person, so we always write this with a capital letter because this is his name. So Pythagoras' theory is aimed at finding the length of sides in a right angle triangle, okay? A right angle triangle. We are not looking at the equilateral triangle and any of the other triangles, but specifically the right angle triangle, okay? So here we found that the long side, which is opposite the right angle, is always referred to as the hypotenuse, okay, the hypotenuse. Now, in the Pythagorean theory states that to find the long side here, we use a square equal to b square plus c square, all right? A being the hypotenuse and b and c the other two short sides, all right? Now, not only can we use this formula to find the hypotenuse, we can also use that formula to find the short sides, okay? So if I were to find b then I would use b square equal to a square, which is the hypotenuse, minus the other short side. Okay. If I wanted to find c, which is this side here, I would have c square equal to a square minus b square. All right? So, Pythagoras theory is equal to a square equal to b square plus c square. And to find the shorter sides, I can rearrange this formula to find the short sides. Okay? So with Pythagoras, we applied Pythagoras to find heights, and also we use Pythagoras in 3D applications. Okay? Following Pythagoras, we looked at trigonometry. All right? Now, trigonometry still aims to find the length of sides in a right angle triangle. Okay? The difference here is we're not only using the sides of a triangle, we are using the angles in the right angle triangle. Okay? Now, with trigonometry, the length of sides are named according to the location of the angle. All right? So if theta were here, this side becomes adjacent, and this side here is the opposite side. Okay, so the trig ratios are ratios of sides using the angle. All right, so those three ratios are known as the sine ratio, all right, which is a ratio of the opposite and the hypotenuse. Okay, so opposite over hypotenuse. Okay, then we have the cosine ratio, all right, which is the adjacent over hypotenuse, all right. Then we have the tangent ratio, which uses opposite and adjacent, okay. In the tangent ratio, we do not use the hypotenuse. We only use the opposite and the adjacent sides. Okay. Now, all three ratios are used to find the length of sides given an angle in the right angle triangle. Okay. So we applied the trig ratios in angles of elevation and depression. Important that you remember that an angle of elevation is formed when you are looking upward, all right? So this is an angle of elevation. And an angle of depression is formed when you are looking downward. Angles of elevation and depression are practical applications of the three ratios that we have looked at so far, all right? Now, moving on, in our last lesson, which was in our last lesson, we looked at bearings, okay? Our bearings is usually given as compass and true bearing, all right? Using the angles that are given. So we use the ratios to identify the angle and then give direction or location as either compass bearing or true bearing. Now a little reminder, a true bearing uses north and south as focal points. So you will find always that a compass bearing will start with north. Okay, let's say north 26 degrees west, or it will start with south and end with either west or east. Whereas a true bearing is a three-figure bearing, always using angle only. So we can have a true bearing of 300 degrees T. Okay, I hope you have or you remember the difference between the two and how we found or red bearings and gave them in both the methods that we looked at in our last lesson. Okay? Now, this ends the recap of our Term 1 topics. In the next segment, we are going to look at how we can apply Pythagoras and trig together. In case you are wondering why we have learned about these two topics, what's the relationship? We'll look at that in the next segment and see how two of them can be applied together. Okay? See you then.